Hi everybody, I'm John O'Connor from New South Wales Department of Primary Industry. We've been running an Exploring Beyond Diesel series over the last few years, and this is a summary version of that, just to try and compress all the important bits into a very short time because we're all time pressed in the modern world. As we get underway, I'd like to acknowledge the traditional custodians of the lands upon which we all are. Down this way on the south coast, this is Yuin country, and you know, it's a good thing that we now will actually know some of our own, you know, the traditional custodians of places that we're running. So it's a good thing. Look, the Exploring Beyond Diesel series popped out of a project. We're trying to figure out where and how do we decarbonise agriculture over the long term, and what the options might be. So this is a summary of that 7-part series. And we'll just go quickly through each of those just so that you can follow the journey, and then you'll have a look at the conclusions and some of the lead-on work that comes from that. Okay, so the series started back in about 2019, 2020 when COVID hit us, and so we sat down and ran long series ones. The latter series, the last 4 or 5, are actually much shorter. So if you go back and have a look at the recordings of the events, you'll find that they're all on the TOCO website and on YouTube, and they're in segments, and you can follow those segments through as you go. Okay, so where we started with was when we looked at the agricultural energy side of things. You find that 80% of the energy going into agriculture comes from diesel, and whilst you can electrify some parts of that quite easily, some parts cannot transfer anywhere near as easily. So we just wanted to try and understand what our options were as we go. There's a lot of things we can do. You know, obviously there's the electric side of things. You can put in battery things. You know, you can transfer the power from diesel to gas to hydrogen to other forms of new fuels. We just wanted to try and understand what the practicalities of each of those were. So we started off with just the logical one, you know, electrify everything, says Saul Griffiths. Let's see if that works. So we talked to Paul Van Ham from Holland. Paul had put together an electric tractor, one of the first in the world, of 7,500 horsepower style. He's been working on it for quite a few years, and we talked with him. He does a presentation in that session in number 1, and that was the big focus. Like, what does it work? I guess the bottom line is it's got a lot of potential. It does work in certain situations, but the horsepower limitations for a lot of the stuff in Australia and the duration for the stuff in Australia is going to be a bit problematic. It's a fit in certain situations, particularly if it can come back to base and recharge and your demand is not too many hours. Works pretty happy, but not for, it's hard to see it a fit for the heavy duty large acreage stuff that's done, you know, in much of the Australian agriculture. So we sort of then looked in number 2. We had Ben Mitchell from Case New Holland popped in, had a bit of a yak about the methane tractor they've got. They developed a series of interesting tractors over time. There is a hydrogen fuel cell one that Case have made. They've also got their methane tractor, runs on methane gas. Again, a good fit in certain situations, particularly in European environments where you've got a closed and intensive agricultural livestock situations where you can capture the gas from the excrement. That sort of works. You can capture your gas, stick it in your machine, use it on around your farm. Oftentimes those farms are relatively small and the duty cycle and use of the machines aren't that long, and so it's a nice fit. But in Australia, we're not so sure that we've got the supply of gas. A few places do, like piggeries, couldn't move across to this technology. But by and large, it's not an easy fit for the broadacre stuff. As I mentioned, that there is a hydrogen tractor that Case brought out. So we were interested in the hydrogen story, and throughout the first 3 of the series, we did have hydrogen speakers. Dr. Neil Thompson popped in and gave us some great insights into the hydrogen industry and how it's made. We had consultants pop in. We had guys who were sort of planning to build hydrogen equipment, and then we had some guys who were sort of like across the whole hydrogen spectrum, sort of, which is what Simon helps it's. So these guys here have been really insightful for us and useful for us to understand the hydrogen potential. It's an enormously brilliant technology, but again, where do you get your hydrogen from? It's difficult. Where do you get the machines from? There's one hydrogen tractor that Case had made, New Holland's made. It's not going to be able to do all the work that, you know, all the tractors are doing. So it's something that can turn up over time, but it's not going to be here anytime soon. So amongst that number 3, we had a guy called Johnny Wapstra turned up and talked about seed to diesel. And the interesting thing about Johnny's position was keep the engine, change the fuel, and don't have to change your machinery. You just change the fuel that goes in it, and you can drop your carbon emissions from whatever they are considerably down. John's process is basically using canola, and you make a biodiesel and feed it back to the farm. And if you want to check that out, it's on number 3. It's quite an interesting process, but it got us thinking about change the fuel, not the machinery. So instead of trying to electrify, you know, electric tractors, methane tractors, hydrogen tractors, let's keep the diesel tractors and stop. Instead of putting in fossil diesel, let's put in a non-fossil diesel and see what we get. So we had a consultant we got a consultant to do some work for us, and Nathan from Movement did that. And he gave us this great little graphic, which we saw earlier on. But really, this is about how do we get from where we are into the future and get to as close to net zero as what we possibly can. And it seems that the bridge has this huge gap that we've been trying to sort of explore. And it looks like while electrification will get you some of the way, hydrogen and the other things we've talked about seem a little bit beyond reach. The green thing there, the biofuels and the renewable fuels, seem to be the logical pathway and bridge across that gap. And the reason that is because they're there. You don't have to change anything. This is a nice little graph that just points out where things are as far as technical readiness goes, and how they rate compared to diesel as far as, you know, wonderfulness, I suppose you'd say. So you can see that the renewable diesel is a nice fit. It's a low carbon option, drop-in replacement, ticks a lot of boxes. A lot of the other stuff, the hydrogen and the electrics, have a lot of potential, but we haven't got the machinery at this stage. We haven't got the power sources to drive that sort of technology, and the availability is sort of not there. So this is why the renewable diesel looks like a nice thing, and the carbon benefits are very significant. So then we got a bit focused, as we got to number 5, we got a bit focused on, let's understand this renewable diesel. I got Allan Schaeffer from the US popped in, and we had a bit of a chat about the significant advantages of the diesel engine and the advantages of renewable diesel. So basically, Allan sort of pointed out we've got a few things. One is that engines are a heck of a lot cleaner now than what they were before. They've got diesel particulate filters. There's an awful lot of technology gone into them over the last 20 years. And it turns out you need about 20 machines now would put out the same emissions or the same amount of ugly and pollution into the world as what one machine did 20 odd years ago. So they're, in general terms, diesel engines are 20 times cleaner. The modern diesel engine is 20 times cleaner than the old sort of ugly ones. So that's a pretty significant thing. The other couple of bits of gold that popped up in Allan's talk was this one. This is the reductions in emissions in California. And the assumption is, or the impression often given is that because it's the go-ahead state in America, and it's got the electrification sort of drive, that the emissions reductions are coming from the electric vehicles. But what is sort of suggested by Allan here is that it's actually the low carbon liquid fuels, the renewable fuels, that are giving the biggest carbon reductions, and it's not the electricity, cars and vehicles at all. So by changing your fuel, you're reducing your carbon at a much greater rate than what you are by electrifying your vehicles, because you don't have to change anything other than your fuel. So that was a sort of give us an insight that we're on the right track here. And that other stuff that Allan presented on this slide here on the left-hand side, you can see the life cycle. These are life cycles sort of from start to finish, life cycle emissions for different fuels that are going to power things. And the ones on the left are all the low carbon liquid fuels, renewable diesel and the like. And as you come through, you've got the fossil diesels and then some of the electric stuff. And you can see that the life cycle emissions on the renewable fuels look incredibly good. The electricities can be good, particularly if you can get a low carbon source, renewable electrons, hydropower, all that sort of stuff will get you down into some very low levels as well. But as soon as you have a bit of a hydrocarbon input into it, or you have a diesel genset or a coal-fired power station or something like that to make your electrons, the benefits of your electric vehicle diminish rather quickly. So that's a really interesting one to explore and understand. So when we're talking about renewable diesel, like what is it? What's it look like? So here's just a picture of it. This is the Neste renewable diesel on the left. So it's clear, it looks a bit more like a water than it does a diesel, and it's much less odorous, it's a lot cleaner and burns cleaner, and it has some advantages as far as if you spill it on yourself and don't have to wash your clothes near as many times to get it to be clean again. But one of the things that Allan did point out that's a really nice one is the time value of carbon reductions. So if we can make a significant change in the short term, that compounds over time so that we have to make much less of a change in the long term. And if we can go to low carbon liquid fuels very quickly, the benefits of that add up each year, and it turns out to be a massive saving as we approach the 2050 timeframe. So understanding that, it's worth having a look at the Allan's one. Look, in 6 and 7, we then had a little bit more of an explore of the renewable fuels world. Simon Roycroft, who imported that Neste stuff, and the Neste renewable diesel. We'll talk about that a little bit more in a sec. But the renewable diesel story and the benefits, Simon outlines those and some of the different ways you can make it. And that sort of got us to thinking, well, let's understand that a bit more. So then we got Professor Rose Amal from the Uni of New South. She gave the talk number 7, which is a highly technical chemistry lesson on how you make renewable diesel. So if you want to understand any of that, go and have a look at number 7. And I suspect you want to look at it twice or 3 times, because that's what I had to do to make sense of it. But incredibly good information and good background stuff to understand. So building awareness of this sort of stuff is what I've been trying to do, and we've been doing that in a project that's involved H2 cuts, hydrogen fuel cell powered woolshed themed barbershop that goes around to agricultural shows and other different events, and has hairdressers on there that cut hair. Pretty novel way to get a conversation started, but it's really the only fuel cell, hydrogen fuel cell that we've seen operating at big agricultural shows. And we've been surrounded, as you have that park there, you're surrounded by like multi-million-dollar diesel engines in headers and tractors and trucks and all this stuff. So if with the only fuel cell sitting there, I don't think the hydrogen fuel cell will be the answer in the short term. We need that low carbon liquid fuel to keep all those big machines that are currently being bought and sold operational for the long time. So the way you do that is we've been looking at it with that Neste diesel, and that's a picture of Mike, the brave Mike Cashin, as we say, with an example of the 2 diesel types with his P2X Express truck, which is run exclusively on renewable diesel for the whole time we've had it, and it pulls that trailer around the state. And I said there's no change been made to that truck at all. All we've done is put that new fuel in it, and there's no risk to warranty, there's no performance difference. It's just a better story all around. The carbon, the only thing that really happens, and you don't notice it, is your carbon load drops by 50 or 70%, or sometimes better. So that's why we're excited about the low carbon liquid fuels. Think that's an answer, the renewable diesel stuff. So look, in a quick summary, thinking about beyond fossil diesel, can it be done? Can we get there? You can actually get there quite nicely with a non-fossil diesel. So you just use it in the current machines, because, as I pointed out, we need to have those machines operating. Otherwise, we're going to be very short of food and fibre and transport options, particularly in the long haul sort of game. And we haven't got the replacements for the low carbon replacement options for those vehicles. The electric versions and the gas versions and the hydrogen versions don't exist yet. So we have to keep the current ones running. And if we're going to keep them running, let's run them on a low carbon fuel. So there's a big reduction. So I say it's 50 to 80, 90% can be sort of done. And it can do it tomorrow, like we did with the truck. It's run 100% on that. But you can also do it in blends. You can sort of start with 1, 2, 5% blends or whatever. So you don't have to be 100% one way or the other. And to put it out, the existing machinery can run on it. There's no problems there. Everything could stay the same. Over time, what we're sort of seeing is likely is these sort of these are bio-based fuels, and that'll mean that there will be a potential income for agricultural producers to produce the bio part of that fuel, and be that an oil or a woody material or whatever. It's got some sort of potential income for farmers over time. So just the last couple of points there. So, fuel security in Australia is sort of always a little bit interesting to explore. The 90-day target that we've got, we're not quite there most times. And if we don't have fuel security, we don't have food security. So that's a fairly significant thing. So we need to be able to make our own fuel to ensure that we can make our own food. And a lot of the food type products that are produced in Australia are actually sent overseas. So a good portion of the canola crop goes overseas. We think we're selling food, but when the people get it, they go, well, good, here's a product we can turn into fuel. So why we don't make it in Australia is still a bit of a mystery, but it's one that we probably need to explore as well. Okay, and as we sort of come to the end of this sort of quick chat, I'd just like to thank those people who've been involved throughout. Mike Cashin and Natasha, the IT guru, is sitting behind the scenes, and then a pile of speakers, sort of John Elderson, Karen Starks and Niels, and a lot of the people I've mentioned have gone through. And a special thanks to James Jackson, who was the president and later ex-president of New South Wales Farmers. He popped into each and every of those 7 events and gave insights from an agricultural point of view, and it's very much appreciated. So thanks for that. Obviously, exploring goes on. When one explorer gets lost in the Arctic, somebody else steps in, I suppose. And other people have been doing similar things. So we're not the only explorers. Bioenergy Australia have come to more or less the same conclusions, interestingly enough, that low carbon liquid fuels, renewable fuels, are a very sensible and practical way to decarbonise. And they had a conference earlier this year in March, and that would be well worth popping in and looking at the recordings of those. They'd be up on their website. Some great stuff in there. One of the particularly nice things that was in there that I think from an agricultural point of view is very important is there was a presentation by Alan Green about the potential for agriculture to produce feedstock for this whole low carbon liquid fuel story. It does involve some genetic modifications and making plants make oil. It's at higher levels, but it's pop in and have a look at Alan's presentation, or look him up on his website and check it out, because it seems like it's got an enormous potential for the future. So that's where we got to. The exploring goes on, and Hope you found that interesting. But check out the original ones if you want to see anything in any more detail, and search into the future and find the answers. Okay, catch ya.